Hello friends, myself R.D. Mahajan presenting my video on function of complex variable integral calculus. In this video I am going to present some important definitions. The first one, singular point. A point at which function is not analytic is known as singular point or the singularity of that function f of z. For example, first function 1 upon z minus 2, this function has singular point. Equating this term to 0, we get z minus 2 equals to 0, that is z equals to 2 is the singular point. Another example, f of z is equals to e raised to 4z divided by z minus 1. This function has a singular point, z minus 1, equating it to 0, we get z is equals to 1 as a singular point, or that z equals to 1 is called as a singularity. Second definition, isolated singular point. If z is equals to a is a singularity of that function f of z and there is no any other singularity within a small circle surrounding that point z is equals to a, then it is said to be an isolated singular point, a singularity of that function. For example, f of z is equals to 1 upon z minus 3 into z plus 3. Equating this term to 0, we get z is equals to 3 and z is equals to minus 3. These 2 points as a singular point, and these 2 points are called as isolated singularity. Third point, third definition, non-isolated singularity. Z is equals to 0 is the non-isolated singularity if in the neighborhood of z is equals to 0 there are infinite number of other singularities. If there are infinite number of other singularities, then that z is equals to 0 is called as non-isolated singularity. For example, f of z is equals to 1 upon sine of pi z. To determine that singularity, we equate this denominator term to 0. We get sine of pi by z is equals to 0. Transferring this to other side, we get pi by z is equals to sine inverse of 0. And standard value of sine inverse of 0 is n pi. Pi get cancelled. 1 by z is equals to, we get n. And therefore, z is equals to 1 by n. With n is equals to 1, 2, 3, we get, that is z is equals to, for n equals to 1, we get z is equals to 1. For z equals to 2, we get z is equals to 1 by 2. For z is equals to, n is equals to 3, we get third one as 1 by 3. Next one as 1 by 4, and so on. We have infinite number of points, and that if we get infinite number of other singularities, then that z is equals to 0 is called as non-isolated singularity. Next definition, Laurent series. Given function f of z is with an isolated singularity at z is equals to a, then it can be expanded in Laurent series about the point z is equals to a as like this. F of z is equals to a0 plus a1 into z minus a plus a2 into z minus a whole square plus so on. Next, plus b1 1 upon z minus a plus b2 1 upon z minus a whole square plus so on. We can extend up to infinity. And next, bm into 1 upon z minus a whole raised to m. Next, bm plus 1 1 upon z minus a raised to m plus 1 plus bm plus 2 1 upon z minus a raised to m plus 2, and so on. And if this bm plus 1, bm plus 2, bm plus 3 all are equals to 0, then we get f of z is equals to a0 a1 z minus a into z minus a plus a2 z minus a whole square plus so on. Next one, b1 1 upon z minus a plus b2 1 upon z minus a whole square, and so on. Last one is bm 1 upon z minus a raised to m. Then that z is equals to a is said to be pole, of order m. Next important definition, a residue. The coefficient of 1 upon z minus a, that is b1, in this Laurent series. Once again I will repeat, the coefficient of 1 upon z minus a, nothing but here it is b1 in that Laurent series expansion of f of z about an isolated singular point z is equals to a is called as a residue. Therefore, that b1 is called as a residue of that Laurent series. Using that Laurent series, we can determine that residue of that function f of z. Then residue of f of z at z is equals to a is given by 1 upon 2 pi I into contour integral of f of z dz. This is the definition of a residue. We'll discuss problems on this residue in my next video. If you like my video, please share it as well as subscribe to my channel to receive the notification of my new videos. For that, you have to press the bell icon. Thank you. Thanks for watching.